If you want to start your career in a mechanical field, static equipment is one of the important topic and one of the important field. You cannot ignore the static equipment. Whenever you go to any plant or any other running sites, you can able to see variety of equipments like pressure vessels, heat exchangers, columns, silos, stack. So what are those? What are those combined together? All this equipment we combine together call it as static equipment. Actually, there are two types of equipments we use in each and every plants. One is static equipment and another one is rotating equipment. In the name itself, you can able to identify that static equipment is the equipment which remains static in the same place. It doesn't move anywhere. But rotating equipment, it moves. It maybe moves to another place or it moves internally with any other shaft, motor or any other thing. In this video, we are going to see what is static equipment, types, examples and also industrial application. As previously I told, all mechanical engineers must know about the static equipment. What is the static equipment? Why we have to learn the static equipment? Static equipment is available in every refinery globally and heart of the power plants, in thermal power plant, in nuclear power plant, in the gas turbine power plants, in whatever power plants, it is the heart of the power plant, essential for chemical, petrochemical and processing, used heavily in pharmaceutical industries, crucial for the modern LNG and the hydrogen facilities. So we are using the static equipment in almost all the industries. So once you start your career, you have to learn the static equipments. And what is static equipment? Static equipment is a mechanical equipment that has no major moving parts during its normal process operations. That I already told about you. What is the difference between static equipment and the rotating equipments? And the primary purpose of the static equipment is storing fluids, contain pressure, heat transfer and also separate fluids. We will go into deep. So here I am having a separate slide for what is the difference between static and the rotating equipment. The static equipment doesn't have any rotating parts, but the rotating equipment has some rotating parts. It must be driven by motor or it must be driven by any engine. Static equipment has some process and it also stores the process fluids, but rotating equipments add mechanical energy into the particular equipment. The static equipments are designed by any other code like ASME, API, EN or any other codes, but designing the rotating equipments requires more experience and each and every organization has their own standards and own specifications and own SOP. SOP means standard operating procedure, how to design a rotating equipments. Each and every companies or organization has their own code or any not code. It is kind of a standard, but it is not a universal standard to design a rotating equipment. And the example for the static equipments are pressure vessels, heat exchangers, columns, tanks. And for the examples for rotating equipments are pumps, compressors, turbines, fans and motors. Almost all these items has a moving parts. Pump has a moving part, compressor has a moving parts, turbines has a moving parts, fans has moving parts and motor also has moving parts. And there are many other rotating equipments. I have listed very limited amount, and also for static equipment I have listed a limited amount. And here we see the major types of static equipments. The first one is pressure vessel, most commonly used in all the plants, and the second one is heat exchangers. This is also most common, but it is not common as pressure vessel, but heat exchangers also we used most common in most of the plants. Storage tank also you can able to commonly see in the process industries, in refineries. Mostly you can able to see in refineries and also in power plants. Columns and towers, these are mostly common for refineries. You can't able to see these columns and towers in large volume in other industries. Mostly it is common for the petrochemical and refineries. Reactors, the reactors are the most common equipments we used in pharmaceutical, in chemical plants, in paint industries, and also you can able to see something in paper and cement industries, but it is most commonly used in pharmaceutical and chemical plants. Boilers and HRSG, boilers and HRSG we normally you can able to see in energy production area, in power plants. And piping systems which is common for all these items, all these equipments which we are going to connect each and every system. Actually it is not a piping. I have not mentioned here as piping or pipeline. It is a piping systems like filters, like stainers. Those kind of things are also called as static equipments. And in next slide we can able to see the pressure vessels, heat exchangers and storage tanks in detail. Pressure vessel, one of the very important one. It is kind of a base for everything. Base for everything means pressure vessel is common in all the plant. Almost you can't able to find a plant without any pressure vessel. Pressure vessel is designed to safely hold the fluids at pressure substantially differ from ambient atmosphere. The common industrial examples of the pressure vessels are air receivers, steam drums, separators, LPG bullets. These are the common pressure vessels we are using in our day-to-day life. And heat exchangers. The purpose of heat exchanger is to efficiently transfer the thermal energy between two or more fluids without mixing them. If we want to transfer a heat energy from one fluid to another fluid without mixing means we will use the heat exchangers. Actually, heat exchangers are different types of heat exchangers are available. One is shell and tube heat exchanger, another one is plate heat exchanger, air cooled heat exchangers, and there are many more. Most commonly used heat exchanger is shell and tube heat exchanger. And storage tanks. Storage tanks is also commonly used in almost all the plants, which is used to store the liquid mostly in the atmospheric pressure. Here we don't give any pressure. Maybe it will be very low in the sense it will be very low by 15 psi. There we use the storage tanks. And what is the difference between tank and pressure vessel? Actually, both are same. No, it is not same. It is completely different. Mostly the storage tanks has very thinner wall thickness comparing to our pressure vessels. It normally used to store the water, diesel, crude oil, and also fire water tanks. Tower and column. Tower and column, in the image you can able to see it is normal pressure vessel. LBD ratio, the diameter by height ratio will be completely different from the pressure vessel. It is normally very high comparing to pressure vessel. That's why we design a little bit different from pressure vessel, and mostly we used in distillation column, absorbers, strippers, and scrubbers. You can able to see these kind of columns in petrochemical industries, and also in process industries. Also some process industries you can able to see, but they are in very small scale. But in large scale we used in the petrochemical industries to separate the petrol, diesel, kerosene, LNG. Those all the processes are taken care inside this column. As I previously told, most vital static equipments are filters, reactors, static mixers, silencers, exhaust stack, and expansion vessel. Here you can able to see these two things, this reactor and the static mixers. These have some moving parts like agitators. Reactors, most of the reactors have agitators. The static mixer 99% has its agitator. But why we consider it as a static equipment? It is not a rotating equipment. It has a rotating part, right? Why we are not considering it as a rotating equipment? We consider it as both static and rotating equipments, where means the vessel we consider as a static equipments, and the agitator, which is mounted in the top, in the bottom, or in the side, which is considered as a rotating equipment. Vessel you can able to design using our static equipment, ASME code, or anything, any other codes. But the agitator you can't able to design with our ASME codes. You have to follow the company standards or any other standards which they are using in the particular organization. Okay. And where is the static equipment used? As I previously told, the static equipments are the heart of power plants, refineries, chemical plants, petrochemical plants, pharma, food industries, LNG, and hydrocarbon. Is there any other industry we have left? Almost in world, almost in all the places, all the plants, we are going to use static equipment. That's why in the initial video I told that it is a very much must important field. You have to learn about the static equipment whenever you want to be a part of it. Why design of the static equipment is very much important. The most of the static equipment must contain extreme pressures, operates at high temperature that will weak the steel, store hazardous, toxic, and flammable fluids, and to ensure overall plant safety and prevents the disaster, enables the continuous production 24 by 7, 365 days. Even in the day shift or night shift, it will run continuously. So to ensure our vessel is in a good condition, and to ensure our vessel is ready for the operation, we need to give very much importance to our static equipments. And if it is designed in a poor way, what are the consequences will happen is there will be a catastrophic failure. There will be no indication before it fails. There will be no visual indication, or there will be no sounds or anything. It will be catastrophic. It will happen in just a second, and there will be a massive environmental damage. If we are having any lethal substance inside a vessel, inside a heat exchanger or anything, if it is leaking and it is a harmful to our environment, means just imagine the situation. It is very much difficult. So designing the static equipment is a really important and a really responsible task. Engineering codes and standards. How we are going to design the static equipments using the codes and standards. First, does the static equipments need a code? Yes, of course, of course. Almost all the static equipments need a design standard or design code. The codes are mostly ASME BPVC, that means ASME boiler and pressure vessel code. API means American Petroleum Industries, Tubular Exchanger Manufacturing Association, and EN means why we are using this code. We are using this code for the design verification, the safety verification. Does we designed the particular equipment safely? Is it ready to be used? For those things we will use the code. How we are ensuring the safety? During fabrication, by inspecting, and also by testing. All this combined for a reliable operation. Career opportunity in static equipment field. It is one of the important topic we need to discuss. Most of the engineers, what they will feel is it is very niche field. How we get the job opportunities? Is it only available in India? Is it only available in a particular established state or in an established city? No, it is available globally. So what are all the career opportunities in the static equipment field is static equipment design engineer, pressure vessel engineer, heat exchanger engineer, proposal and estimation engineer, stress analysis engineer, QA QC and inspection engineers. The static equipment engineer you already know, which we are. Pressure vessel engineer, it is a specific engineer who design only the pressure vessel. Heat exchanger engineer, as I already told, some industries have only pressure vessel manufacturing, some industries has only heat exchangers manufacturing. So they want a particular specialist in those engineering. Proposal and estimation engineer, most common in almost all the EPC companies, fabrication industries, or any other places. It is most common job. Proposal and estimation engineer. Stress analysis engineer. Actually, stress analysis engineer in the sense we have FEA analysis. We have our normal ASME section 8 division 1 analysis, which is design by rule and design by analysis in ASME section 8 division 2. Those kind of engineers will be called as stress analysis engineers. We also do the FEA for our pressure vessels, for our critical nozzles, for our critical supports. Those engineers will call us stress analysis engineers. And also we have material engineers, maintenance engineers. There are many field and many specified engineering available in our static equipment opportunity. So it is a very good career opportunity. Okay, we are going to end this video. In our next video, we will see about the detail of pressure vessel, heat exchangers, and other equipments. Keep learning. Bye bye.